Hi students, welcome to this course, PLC Automation, an Introduction to Programmable Logic Controller. I am Professor Yao. Circuit protection and wiring. The keywords: electrical circuit protection, fuses, circuit breakers, or device overload protection. The various types of fuses available. Electrical circuit protection can be carried out by fuses, circuit breakers, and device overload protections. Protecting the PLC requires adequate fusing and proper wiring in its feeder circuits. Inadequate fusing can lead to PLC damage, and inadequate wiring can lead to improper operation. Figure 27.4 illustrates some of the various types of fuses available. Various types of fuses. The major consideration in choosing a fuse. The keywords: rated current, interrupted, one-time operation, time delay fuses, excess line loss, voltage drop, the feeder wash resistance, power waveform distortion, surge from lightning. Some of the major considerations in choosing a fuse are: rated current for melting or blow, rated current of the PLC, interrupt capability, temperature of environment in which the fuse will operate, type of mounting, replaceable link or on one-time operation, time delay or regular. Do not use time delay fuses for PLC. Use regular fuses. Other special requirements. Wiring must be adequate. The wire size must be large enough to prevent excess line loss when a current is drawn by the PLC. Line loss is caused by voltage drop due to feeder wire resistance. Figure 27.5 shows wire resistance values for various wire size. Electronic equipment, including PLCs, can be affected by power waveform distortion. This is the wire table. American wire gauge, AWG size for solid round copper. Some of these possible waveform distortion are shown in figure 27.6. Correction of this waveform distortion can be accomplished by the use of line purifier unit. See figure 27.7. These distortions can be caused by one of the following: surges from lightning hitting power lines, disturbance from adjacent buildings or factories, surge from switching action by the power company or in your plant, internal factory-powered waveform disturbance. This is a possible AC waveform distortion. This is the power purifier or conditioner unit. Troubleshooting PLC malfunction. Keywords: turn off the power, wear safety glasses, an electrical flash or small electrical explosion. What is malfunctioning? Some troubleshooting procedures have general application to all electromechanical devices, and PLC are no exception. Safety is the primary consideration during troubleshooting procedures. Turn off the power when walk inside of the devices, unless power is necessary for the analysis. Wear safety glasses during circuit checking in case of an electrical flash or small electrical explosion. Most important, work in the laboratory and consider the consequence of each step of checking procedure. Once general safety precautions have been taken, you are ready to proceed into malfunction analysis. One major step is to understand exactly what is malfunctioning. Document the problem in detail, including the date, time, severity, and the circumstances of malfunction, and include a second opinion if one can be obtained. Verify that the reported problem actually exists before trying to solve it. Checking for and replace any broken fuses. A complete visual inspection may reveal the cause of the malfunction. Is there power to all control circuits? Are there any broken wires? Are switches set in the proper position? Have any undocumented alteration to parts been made? Unique troubleshooting procedures establish that system malfunction is not caused by an external part or system. Check the PLC itself for proper operation in each applicable mode. Call up the status and refer to the operating manual to determine what the CPU display should look like to indicate proper operational conditions. An impulsion not meeting the norm shows an operational problem areas. In addition to the CPU status screen display, many PLC have available a fault indication register display. A typical fault display is shown in figure 27.8. The figure includes a display and interpretation sheet which is found in the operating manual. Other displays with more specified information are available on some PLCs. A message on one of these PLC might say output 0024 is shorted or register 043 is not working, for example. Another PLC troubleshooting aid is sequential listing of troubleshooting steps in an operating manual. The list can be in consecutive form as shown in this example. Turn on operating switch number 7, key switch to run. Light number 4 must light. If light number 4 does not light, check bulb. If bulb is okay, put OR is in address 909, etc. Other sequential listings are in computer diagram form. See figure 27.9 for an example. By following the flow diagram, the subsystem may be checked for correct operation or determination of a malfunction. Upon determining the causes of PLC function, corrective action is taken. Unusually, corrective action involved replacing a faulty part with a new part. If the system still doesn't work when a faulty part is replaced, there are 3 possible reasons. The part used for replacement may also be faulty. There may be another part or parts in the unit that are also faulty. The replacement part fails when it is installed because the original defective part have failed due to an overload caused by some other malfunction of the system. A written log of failures and the corrections for each PLC should be kept. The log will show if there is any failure pattern after a number of entries are made. This is a typical CPU fault mode, register display and interpretation. Fault mode register. This is a typical PLC troubleshooting flowchart. Homework. Handwriting all keywords and submitting them to course Facebook. Just do the online quiz and see you next time.